Hey guys, welcome back. Oh, you probably didn't hear that. Let me move my mic closer. Hey guys, welcome back. This is your lottery and I'm playing Kerbal Space Program. I was messing around off camera and accidentally orbited the moon. Well, it wasn't entirely accidentally. I meant to just do like a test flight and then roll it back if the rocket worked. But I got too enthused and actually orbited the moon and then made it back intact with mystery goo and a material study. So I just got a boatload of science and you guys missed it. I'm so sorry. Maybe I'll just rerun the mission, but I think what I'll do instead is actually try to land on the moon. I don't think it'll be that hard. This rocket worked really well. I'll show you the rocket I used anyway. Tons of science. Look at that. 75, 23. The reason this wasn't full value is I transmitted data first, just in case I didn't make it back. And I also transmitted EVA report and a crew report. So I have 176 science. Here's the rocket. Maybe. It worked really quite well. The Science Junior, couple mystery goos. I had one to transmit, one to carry back. 3 parachutes because this entire top thing was my return lander, not just the capsule. So it was a lot of weight. Landing legs. I landed in water, so those weren't necessary. But I meant to land on land. I didn't orbit Kerbin when I came back. I just re-entered and touched down. There is one little engine here with a fuel tank. This was my my return fuel tank, and it actually ended up being my get into orbit around the moon and do the return fuel tank. This stage here was my go from Kerbin orbit to lunar intercept, and it actually ended up being my finishing my Kerbin orbit as well. And then the first stage, which consists of all this stuff, technically it's more than one stage. Okay, I have 4 liquid fuel rockets and 6 boosters, 3 large ones and 3 small ones. And the solid boosters fire first, and then when I get rid of these shorter solid boosters, then I turn on these puppies, the liquid ones. So I have more liquid fuel high up to get my orbit. And most of the heavy lifting in low atmosphere is done by these guys. Yeah, it worked really well. Let's I'll do launch and then I'll recover just to show you how the launch worked. I'll rewind this after I do it, after I launch it. So stabilize boosters. The fins help keep it nice and stable. Solid fuel's burning. I'm already at 120 meters per second and I haven't fired my liquid thrusters yet. There's a bit of flex in there. First booster's away. And now I'm slowing down, so I'm going to fire off my liquid boosters. Get the speed back up there. Solid engine's away, and then this is the stage to orbit. And I'm going to start rolling it over, starting my gravity turn. Quite perfected how to do this yet. Because the SAS wants to keep bringing it back to vertical. I'm not sure why. if you look here, my apoapsis is already like almost 50 kilometers. Just drag the turn over a bit more. Yeah, and we're already got apoapsis in space, so cut power and coast. And when you get there, we're going to add a maneuver and circularize our orbit. Probably actually do it right about there. 184, it's too much. There we go. That's nice. $79 and 91, that'll do. So there's my aiming thing. Gotta be there in a minute, but I'll actually start my burn sooner. Oh, overreached it. It's kind of hard to steer at this point. Okay, so this is a 45-second burn to circularize my orbit, but we're actually going to run out of fuel on this stage before that's done, and then it'll take longer. So I'm going to start it at probably 25 seconds too, like there. And then the stage goes. And see, now it's a minute burn with this stage because it's only got the one engine. But that's okay, it'll work. See, it's burning quite a lot of that fuel, but that's okay. We're almost done the burn. Done. So now we have our orbit. We can get rid of this node. And we have a nice... Oh, actually it's not very nice. It's only 61 there. That's not good. We need to... we need to correct that with one of these guys. Yeah, that was bad. You want to keep your orbit above 70 kilometers. There we go. That should fix it. Yeah, now we have periapsis at 75. Okay, so the next thing you do is you go to your moon and you set it as target, and then this gives you an ascending and descending node. What these are is where your orbit intersects the moon's orbit. And, you know, mine's actually really bad right now. Which way are we going? Okay, so in the descending node, I'm going to add a maneuver, and I'm going to correct our axial tilt. You see how my orbit is not on the moon's orbit? So I'm going to go like this. Oh, no, wrong way. I'm going to go like this, and try to get it to match. Okay, that's about perfect. There's always going to be a line where the very slight angles change, but the way this dotted line like whips around really fast and goes 90 degrees, that tells you you've pretty much got it perfect. So this should be a short burn. It's 8 seconds and happens in 12 minutes. So we'll get over to where we need to be, which direction we need to point. Right there, approximately. We'll advance time a bit. 11 minutes, 10 minutes, 9, 8, 7, 6, 5, 4, 3, 2, 1. Slow down time. Not that much. 10 times. 1 minute, 50 seconds, 40 seconds, 30 seconds, 20 seconds. Okay, ready for the burn. In 8 seconds. 7, 6, 5, 4, 3, 2, 1. Begin burn. And burn. So that flattened out our orbit. The next thing we do, we get rid of this orbit node, because this maneuver node, is we go and we add a maneuver, and we want to burn prograde until the Apophis is just outside lunar orbit. Like about there. And then this is where our closest approach, target position at closest approach, so we need to swing this thing around. See, now we have a lunar encounter. And then we go and we adjust it. This gives a moon periapsis of 187,000. We can adjust that by going like this. There are 14,000 lunar periapsis. That's a really close orbit. Let's not quite do that much. 29,000. See, there we go. That would be a great, nice, tight orbit around the moon. And then all we have to do is wait till our ship is there, which is in 15 minutes. Well, might as well do it. We got to aim the right direction. And we'll advance time. You're going to need a course correction before we get there, but we can do that with a couple minutes to spare. 4, 3, 2. Okay, a couple minutes to spare, so let's do that course correction. Okay, that should be good. And speed up time again. It's a 26-second burn. We're almost out of fuel, though. I don't think we'll have the 26 seconds, but that doesn't matter. We have another stage. Okay, begin burn. And we're out of fuel, so we'll use the next stage. And if we bring up the map screen, you can see our Apophis grow. Check our fuel. I think I did better on the first trip out, fuel-wise. I could throttle down and be a bit more efficient. The Apophis starts growing faster and faster as your burn gets near completion. Three, 2, 1. Oh, a little bit more. Uh-oh. Okay, I'm not quite sure what happened there, but we'll find out because we'll delete this node, this maneuver node, and say goodbye to Kerbal. We will be leaving you now. Goodbye, Kerbal. It was nice knowing you. There's the moon. This might be a crash course. Oh, there we go. Periapsis of 420. Not as good as I hoped, but it'll do. Oh, why'd that switch again? Alright, let's slow down time. Gee, it's too much. It takes hours to get out here. Ah, here we go. Okay, so we're going to plan a maneuver at the periapsis of the moon to burn retrograde and bring us into a nice circular orbit. See? Easy. 13-second burn in 47 minutes. Make sure we're facing the right direction. It's going to be the other side of the nav ball. Speed up time. So I guess we're doing another complete mission. Might as well get the extra science. It's not a lot, but it'll be some. $12 minutes. Whoa, 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 I missed it. Should be okay though. Alright, we're in orbit anyway. Wasn't quite as good as I hoped, but it'll do. Okay, so now we're in orbit around the moon at 400 kilometers. My first one was tighter, but there's the moon. Check it out. Now we can go crew report. 0 science. We can go EVA and EVA report. 0 science. We've already done this. Okay, board. Observe mystery goo. 5.3, we'll take it. Nothing for transmitting it. Let's observe this mystery goo too. Another 5.3. It might not count them both. It might just be saying, I doubt I'll get both. And can't I observe the materials? There we go. Observe the materials bay. 16.4. Keep the data. And then we have to plan our trip back. So I'm not quite sure yet of what the best way back is. I think it is like burn. You want to escape the moon, so I think it's burn at periapsis to obtain escape velocity from the moon. Yeah, there we go. And then adjust this maybe. That's about the closest. Let's see if we give more power here. 1,000,000 kilometers. Try spinning this again. 1,000,000. 600,000. Oh, there we go. See, 19,000 meters. That would be good. That would be functional. And I'm sure I've got 12 seconds of fuel left. So this is in 2 hours and 30 minutes. And the direction we need to face will be here. Speed up time. Okay, 36 minutes. $16 minutes. 10 minutes. 4 minutes. Okay, 18 seconds. Nice on the time controls there. I'm going to watch from this view. Okay, I think I did it. Oh, that's actually course into the planet, but we'll fix that in a minute. We'll just get it out of the moon's sphere of influence. There we go, and then we can just accelerate. We're close enough to the apotheosis. We can probably just accelerate prograde. Why can't I maneuver? There we go. Where's my prograde marker? Oh, there's it. We could probably actually land with it as it is right now, but I'm just going to give this a little touch of thrust. There we go. 15,000 meters. That'll do. And we don't actually need the stage anymore. We can abandon it. I kept it and burned the last of the fuel incoming. I don't think it makes a difference. I'll just eject it here. I think. We'll keep it in case we need to do a course correction. We're still far from them, from Kerbin. Thousand times speed. It does take hours to get to the moon. In real life, it took the Apollo astronauts 3 days. Okay, I'm just going to burn the rest of my fuel to bleed off the... I'll do it a bit closer to periapsis. Now I want to burn retrograde. And that'll do. I'll just burn off the fuel. Bleed off some of that speed, just because I have no use of the fuel up here, and then we'll eject that. There should be 2 pieces floating here now. And it looks like we're going to be landing on the light side in the ocean. The last time I landed in the dark in the ocean. Now if you want to land in a specific site, you're probably better off carrying extra fuel and going into orbit around Kerbin, or maybe just clipping the atmosphere to slow down so you don't have to use as much fuel, and then you can, choose where you decide to go out of orbit. There's my my debris that I just ejected. Alright, let's speed up time. Oh, throttle down, speed up time. 400 kilometers, 200 kilometers, and our time's going to crash, yep, to 1, because we're now in the atmosphere. And we want to be pointing in the direction we're going for the, I don't know if it makes a difference, but I like to re-enter bottom first. Right now there's no heat part of the game. It shows the heat of re-entry, but it doesn't actually heat up your stuff. They are going to add that in, and eventually it'll make re-entering the atmosphere a lot harder, because you'll have to worry about how hot your vessel is getting. So now you'll see our velocity starting to drop. Jebediah is smiling. You can see our orbit dropping rapidly as we're losing our velocity. 16,000 meters. 1,000 meters per second. At around 300 meters per second, I'm going to pop the chutes, unless I need to pop them earlier due to altitude, but I think I should be okay. Shoots and SAS off and gear out. I don't think it makes a difference for the water, but whatever. Now this takes a bit of time because I'm still 5 kilometers up, and you don't want to mess with the physics too much when you're under shoots, because if you speed up the physical time warp, your chutes can rip off and you can crash and stuff. I'll wait till my velocity is stabilized, and then I'll speed up a bit. I think it stabilizes around 85. (2,200 meters altitude, 94 meters per second, dropping speed. You know, I might just let it fall at this rate. It's not going to take too long. Jebediah is smiling. He's a happy guy. Alright, now I will speed it up because it's going to take a while to fall at this speed. Half a kilometer at 4 meters per second. (250 meters, 200 meters, 150 meters, 100 meters, 50 meters, 30. All right, down to regular speed warp. And we should just gently land in the water. Did it this time. Here we go. Perfect. Where's the hatch? Thinking about pulling Jebediah out for a EVA. Nothing. I can't take a surface sample either, so get back in there, recover vessel. So I won't get as much science this time, but that's what my mission basically looked at, like the one I did off camera. Did get some science though, so we're up to 25.6, not bad. Okay, so I'm just going to quickly check the time here. That is 25 minutes. So what I'll do, no wait, this one is not telling me because I'm still recording, derp. Okay, I'll just look at the tech real quick and then we'll call it an episode. So we have all this stuff, which is cool. This is the next one of the 45 science ones. It gives us strut connectors, launch stability enhancers, a different radial decoupler, and a tri-stack coupler. And that's pretty good. Let's buy that. And that opens up this thing, which is advanced construction. Hydraulic detachment. Okay, well, that's cool. Let's see what we have up here, though. We can afford one of these 90 things. Heavy rocketry. Just a big engine. And fuel tank. We have fuel systems, which gives this Rocco Max, which I think is a tiny, like for probes or something. And RCS and fuel ducts. Ooh, I might get that. We have aerodynamics. I'm not really interested in doing space planes per se yet, so we'll skip that for now. We have advanced flight control, which gives a new cockpit, probe, inline stabilizer, and a delta wing. We have electrics. Ooh, solar panels. That's tempting too. Batteries, solar panels, lights. I want those for landing on the moon. Space exploration, mobile processing lab, ladder, thermometer, which gives me more science, I think. And landing. Struts and gear. Okay, well, you know what? These all cost 90. I think it's a toss-up between electrics and fuel systems. And I think I want both. But I can't afford both. We're going to go with fuel systems, and we can always just pack micro batteries. As long as I'm not doing like a long-term trip or doing like roving or electrical stuff, I think that'll work. Because these things you can use to link tanks and do like liquid staging, where you have like several engines all running at once, but the outer ones are pumping their fuel into the center tank, so it doesn't empty as fast. And when the outer ones are empty, you can eject those and carry on burning. So you can like shed weight without, and preserve fuel. That opens up these two things, which I can't access. Why not? Doesn't even show them. I'm guessing they all take multiple things or something to get to. Don't know. Why are these all numbered? Oh, it's the number of items you get from it. Okay, well, that was it. That's our episode. Next time, I think I will try to build a moon lander. To touch down on the moon and then come back. I'll make sure I record that, even if it's a crashing failure. See you guys next time. Thanks for watching.